Your monthly cloud bill shows $400 for just 3 API routes. They're all GET requests that should be cached, but they're not, because each one reads the authorization header. The article tests on Next.js 16.0.0 Canary. In Next.js 15+, the params prop in route handlers is a promise and must be awaited. This syntax is required in the article's examples. In Next.js 14 and earlier, params was a plain object. Ensure your project uses the correct version to avoid runtime errors. The article mentions that reading search params makes a route dynamic. To access search params while keeping the route cacheable, you can use next request and read next URL. Search params only if needed. Here's a pattern that conditionally uses search params without making the route dynamic if they are not read. The data cache persists across deployments by default. When you deploy new code, cached responses from the previous deployment may still be served until they expire or are manually invalidated. Use Revalidate tag or Revalidate path in your deployment script or leverage Versal's automatic cache invalidation on deploy to ensure users get fresh data after updates. Let's break down route handlers, building API endpoints in Next.js 16, how it works, and the exact mistake behind that failure. JS route handlers. We'll cover how caching works, why some routes cost money, and how to build secure, efficient API endpoints. Route handlers are API endpoints defined in route.ts files inside the app router. They export functions like GET or POST and receive standard web request objects. GET requests are automatically cached using the data cache, while other methods always run fresh. A GET route is cacheable if its response depends only on URL path parameters. If it reads request headers, cookies, or search params, it becomes dynamic and runs on every request. That's the key difference that impacts your bill. Here's a cacheable GET route. It only uses the userid from the URL path. The fetch call includes a revalidation time, and the response sets cache headers. This route will be cached after the first request. Now compare with this uncacheable route. It reads the authorization header to get the user ID. That single line makes the route dynamic, every request runs the full handler, and caching is disabled. Cached routes can be revalidated in two ways. Time-based revalidation expires the cache after a set number of seconds. Event-driven revalidation uses tags. When data changes, you call revalidate tag to immediately invalidate the cache. Time-based revalidation is simple. Set revalidate to the number of seconds you're willing to serve stale data. Here, products are cached for 1 hour. Tag-based revalidation gives you immediate cache invalidation. Here, the GET route tags its response. When a server action creates a new order, it calls revalidate tag to purge the cache instantly. Route handlers are for external API consumption, mobile apps, third parties. Server actions are for internal mutations from your own front end. They can work together. A server action can call a route handler internally for shared business logic. Here's the hybrid pattern. The route handler is the public API. The server action is called from the form and internally fetches the route handler. This keeps business logic centralized while giving you the benefits of server actions for the front end. Route handlers can stream responses using readable stream. This is useful for real-time events like SSE, but streaming disables caching. Every request runs the full handler. Use it only when you truly need live data. This example streams server-sent events. Each event is sent as a chunk. Notice the cache control header is set to no cache. Streaming responses are never cached. Route handlers are raw HTTP endpoints. They have no built-in security. You must implement authentication, CORS, rate limiting, and input validation yourself. Create shared helpers to avoid forgetting. Create a utility module with helpers for CORS, Auth, and error responses. Use them in every route handler. This ensures no endpoint is left unprotected. Route handlers follow strict conventions. The file must be named route.ts. Each HTTP method is an exported async function. URL params are accessed via the second argument and search params via next request. Here's a complete route handler with get, post, delete, and options. Note that options is needed for CORS preflight. Also, reading search params makes the GET route dynamic. Let's look at the numbers. 3 cached GET routes at 1,000,000 requests each cost about 0.06 of a dollar. 3 uncacheable routes doing the same work cost $400. The only difference is whether the route reads an auth header. This cost calculator shows the difference. For cached routes, only cache misses count. For uncached routes, every request adds up. Use this to estimate your own costs. This is the same issue we highlighted at the start. Here's exactly why that happened. A team had 3 dashboard routes that read the authorization header to identify the user. This made them dynamic. Every request ran the full handler. They assumed API costs were normal, but the real issue was a missing cache. Reading the authorization header from request headers makes the GET route dynamic and uncacheable, causing full compute cost on every request. Moving the user ID to the URL path makes the route cacheable. The fix was simple. Move the user ID from the auth header to the URL path. The route became cacheable because the response now depends only on the URL. Mutations were moved to server actions. The monthly cost dropped from $400 to $15. Reading the authorization header is the most common reason a GET route becomes uncacheable. That single line forces every request to run the full handler, costing you money. Route handlers don't add CORS headers automatically. If you forget them, external clients will get CORS errors. Always add access control allow origin headers. Next.js only recognizes files named route.ts for API endpoints. If you name it something else, the route won't exist. Always use route.ts. To debug route handler issues, first check if your GET routes use any dynamic APIs. Then verify Revalidation is set up correctly. For CORS issues, ensure you have an options handler. Use the cost calculator to identify expensive routes. Let's run through some common interview questions. How does Next.js route handler caching work? Get routes are cached by default if they don't use dynamic APIs like headers or cookies. When to use route handler versus server action? Route handlers for external API consumption, server actions for internal mutations. How to diagnose $400 month cost? Check if GET routes read auth headers. Move user ID to URL path to make them cacheable. And a few frequently asked questions. Are all GET routes cached? Only if they don't use dynamic APIs like headers, cookies, or search params. Can route handlers be cached for post? No, only GET routes are cacheable by the data cache. Do route handlers have built-in auth? No, you must implement auth manually. Let's recap the key takeaways. Get routes cached by default if no dynamic APIs. Move user ID from header to URL path for caching. Use server actions for internal mutations. Implement auth, CORS, rate limiting manually. Ready to go deeper? Up next, authentication in Next.js 16. Auth, JS middleware and route protection, then the Next.js 16 caching model, data cache, full route cache, and client cache, then incremental static regeneration ISR in Next.js 16 and server actions deep dive, forms, validation, and progressive enhancement. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.